Simple definition for force is any push or pull on an object. Now, I don't mean it has to be a literal push, okay, or a literal pull. For example, you could push a couch with your hands, but gravity could pull the couch down a hill, okay? You could pull your friend by their arm, but you could also pull your friend with a tug-of-war rope, okay? The ground pushes up on you to keep you from falling through the floor, okay? So there are lots of examples of things that are pushes or pulls. Friction pulls you back as you go forward. So there's lots of examples of these pushes or pulls, which is why I don't really like this as a definition, because I don't think it's complete enough. So let me give you the better definition that is going to be more helpful in understanding how this works. And that's this. So a force would be any action that can, not that it does, cause a change in an object's motion. In other words, an acceleration. Acceleration is a change in motion. So, a force is anything you do to an object that can cause its motion to change. Not that it does. For example, gravity right now is not changing my motion. Gravity is pulling down on me, but it's not changing my motion. And that's because the ground is pushing up on me. But gravity can change my motion, like if I jumped out of a tree. If I jumped out of a tree, then gravity would pull me down. It would change my motion. Okay? So, it can cause a change, but it's not right now. Pulling on someone while they pull back. That could cause a change if you're stronger, but it may not if you guys are equally strong. So it just depends on what that is. But I think that's a better definition because it's a little clearer on what actually makes a force. Force is something that can cause an acceleration. Okay? If it can't cause an acceleration, it's not a force. There are three what are called imaginary forces. We'll talk about one of them. It feels like a force, it looks like a force, but it can't actually change your motion. And so it's not actually a force. All right, one last thing to look at here, and that is going to be net force. So net force is the total force on an object in a particular direction. And what I mean by that is either the x or y direction. Yep, still got to do x and y like last unit. Good news, we're not going to combine them together. We're not doing Pythagorean theorem, we're not doing tangent, cosine, we're not doing any of that. We have to separate them from each other, but we don't have to do them at the same time. Okay? So we'll do the x's by themselves, we'll do the y's by themselves. So let me show you an example of how this works. So let's use a car driving on the road. Okay, so here's my car driving on the road. Okay, so it has several forces on it, things that can cause a change in motion. They may not be causing a change right now, but they can. For example, the engine can cause the car to speed up. So we would call that the force from the, we'll just call that force engine for now. There's better words for these things, but for right now we'll just go with that. So there's a force from the engine that can cause it to speed up going forward. There's also a force from the brakes, right? If you hit the brakes, they can slow you down. That would cause a change in motion. Okay? There's also gravity pulling down. Gravity could cause a car to fall downwards because that's the way gravity pulls. But gravity is also pushed up by the ground. The ground could also cause a motion up. For example, if the ground could push up, that would change its motion. Like if there was a magical volcano underneath the car all of a sudden, which would be surprising, but there could also be a force from the ground. Again, these all have actual names to them, which we'll get to, but for right now, I'm just going to kind of have them as their forces. So if I wanted to figure out how this worked, I would have to figure out the net force in the x direction by adding the s forces. So the net force would be the force from the engine plus the force from the brakes. Sorry, it's a little small there to read. And in the y direction, I would do this as well. In the y direction, the net force would be the force from the ground plus the force of gravity. And that's all the net force is. It's just a way to figure out the total value on an object. Okay? Just to figure out how much force is there overall. And again, we'll get all into this a little bit more. Right now we're just doing the definition. That's what we're going to use when we solve some problems, will be net force. But right now it's just okay just to do the definition. Okay, any questions for me on what a force is or what it does? Woohoo! Okay, let's go on and talk about the other three laws here.